With the information regarding ventilation, let's look at some important definitions and some numbers or volumes and capacities lungs have. Minute ventilation, that is, how much air is exchanged in 1 minute. It depends on the number of breaths per minute. Each breath in a resting situation takes about 5 seconds. Therefore, 12 per minute. The range is much wider. You can say 10 to 30 breaths per minute is still normal. So, in each breath, approximately 500 milliliters of air is brought in and brought out, and that's what you call as tidal volume. And 500 milliliters per breath times 12 breaths would be about 6 liters. 6 liters of air exchanged in a normal situation per minute. So that is the rate or frequency of respiration. Anatomic dead space, that is the part of the airway that's not involved in gas exchange. So it's still with air, that air will not participate in gas exchange. That adds up to about 150 milliliters of air, anatomic dead space. Alveolar ventilation. So if you subtract 150 milliliters from 500 milliliters, because 150 milliliters is not available for gas exchange, it's going to be 350 milliliters that actually arrives in the alveolus. So the alveolar ventilation is always going to be less than the normal tidal volume. So amount of air per minute that enters the parts of the respiratory system in which gas exchange occurs. Other numbers and capacities to talk about. So the yellow area here is showing normal volume of air that's brought in or released. Okay, that is tidal volume. This increased level that you see here is when you take a deep breath, the maximum amount of air you can bring into the lungs. Take a look, it goes quite high, many times more than the 500 ml. So that could be about 3 liters of additional air that the lungs can hold. And that's what you call as inspiratory reserve volume. Reserve is the hidden capacity of the lung to be able to hold more air than normal. Expiratory reserve volume, similarly, is where one can release maximum amount of air out. Note that the amount of air the lungs can release is not the same as the maximum amount of air that the lungs can hold. So there is this maximum amount of air that you can release. It would only be about 1200 ml of air, not like 3000 that we saw here. This poses a question, why is that? Why can't lungs give off all of the air? Nope, that would mean the lungs are collapsed. So in order for the lungs to remain open, there should be so much air within the lungs, and that's how the expiratory reserve volume is smaller compared to inspiratory reserve volume. Residual volume is the amount of air left in the lungs at the end of expiratory reserve volume. So you have released maximum amount of air you possibly could, and there is still so much air, and that adds up to about 1200 ml of air as well. So those are some terms we talked about: inspiratory reserve volume, tidal volume, expiratory reserve volume, and residual volume. Now let's talk about inspiratory capacity. So this is tidal volume and this is inspiratory volume. If you combine those, then you get inspiratory capacity. Functional residual capacity is where you combine residual volume and expiratory reserve volume. Then you get functional residual capacity. Vital capacity is where a person can breathe the maximum amount of air possible in and out. So you're combining expiratory reserve volume, tidal volume, and inspiratory reserve volume. Vital capacity can be defined as a person breathing at a maximum capacity, inspiratory reserve volume, expiratory reserve volume, as well as tidal volume. So it could also be defined as inspiratory capacity and expiratory reserve volume. Total lung capacity is the combination of inspiratory reserve volume, expiratory reserve volume, residual volume, and tidal volume. That adds up to about 6 liters.